In this video, let us look at J.J. Thomson atomic model. J.J. Thomson atomic model is also known as what? Plum Budding model. Please take note of this. Plum Budding model. J.J. Thomson atomic model is also called Plum Budding model. What is the experiment he used during his own world discovery of subatomic particle? He used what? He used cathode ray tube experiment. He used cathode ray tube experiment, which is called CRT, cathode ray tube experiment. J.J. Thomson used cathode ray tube experiment to discover electron. J.J. Thomson was the man that discovered electron. He used what? Cathode ray tube experiment, CRT, cathode ray tube experiment. And the model, J.J. Thomson atomic model, is also known as what? Plum Budding model. How did he use the cathode ray experiment? Let me quickly give you the tool, because for Jupeb students is there, they can ask you to draw a cathode ray tube experiment according to J.J. Thomson and explain how he used it to discover electron. Take note of this. It's a simple diagram. When you have a glass discharge tube, this is known as what? Vacuum pump. The function of this vacuum pump is to lower pressure, the pressure of the gas inside the glass discharge tube to about 10 raised to the power minus 4 atmosphere. The function of this is to lower the gas pressure and to maintain a low pressure. To lower the gas pressure, to maintain a low pressure. Then we have cathode electrode. This is a cathode electrode. On this other side, we have a screen which is made up of what? Zinc sulfide. The function of this zinc sulfide is to detect the flow of stream of particle produced from the cathode electrode. This is cathode electrode. Then on this other side, we have the anode electrode. This is anode electrode. Or let me put it somewhere else. Let me put it here. Anode electrode. That is positive electrode. Cathode electrode, negative electrode. This is a screen which is made of zinc sulfide. Take note of that. Then both the anode and the cathode electrode, they are connected to, these two electrodes are connected to a source of electricity. The cathode electrode is connected to the negative terminal. The anode electrode is connected to the positive terminal. Then what happened during this setup? We have ammeter here. Ammeter is to detect the flow of current, if current is being produced. Then when this setup is being done, you supply electricity. What happened? The cathode electrode produces particles. This cathode electrode produces a stream of particles which moves from the cathode electrode towards the anode. This stream of particles from the cathode electrode, they move towards the anode. Then on getting towards the anode, they eat. When they fall on this screen, they produce what? A glow. They glow. That means they produce tiny green light. They produce tiny green light. When Thompson saw that, he discovered that this cathode electrode is producing stream of particles. When he saw or observed glowing of this screen, glowing of this screen, which is made up of what? Zinc sulfide. When he saw the glowing of this screen, which is made up of what? Zinc sulfide, he now observed, he discovered, or he concluded that stream of particles are flowing from the cathode electrode towards this side. Then he called the stream of particles cathode ray. He called the stream of particles cathode rays, which are negatively charged. Take note, cathode rays are negatively charged because they are produced from the negative electrode. Cathode rays, they are negatively charged because they are produced from cathode electrode, which is negative electrode. Cathode electrode is a negative electrode that produces what? Cathode ray, which are negatively what? Charged. Then later, the cathode rays are called what? Electrons. Because electrons are negatively charged. The cathode rays are called electrons because the electrons are negatively charged. Don't forget, the cathode electrode produces what? A stream of particles which move from the cathode electrode towards the anode, and they fall on the screen. They produce what? A tiny green light, or the screen will glow. Take note of that. And those stream of particles are called cathode ray because they are produced from cathode electrode. They are negatively charged. Later, they now call it what? Electron. Electron. Then let us look at the characteristics of cathode ray, which is very important for Jamb student, for Jupeb student, for underlevel student. Very, very important. Characteristics of cathode ray. Very, very important. Very. Characteristics of cathode ray. Characteristics of cathode ray. Characteristics of cathode rays. Let me give to you. Number one, they are negatively charged. Negatively what? Charged. Take note of that. They are negatively charged. Cathode rays are negatively charged. Please take note of that. They are negatively charged. Why? Because they are produced from cathode electrode. And cathode electrode is a negative electrode. They are negatively charged. Number two, they move in straight line. They move in straight line in the absence of electric and magnetic field. Take note of that. They move in a straight line in the absence of what? Electric and magnetic field. They move in a straight line in the absence of what? Electric and what? Magnetic field. Number three. They are invisible, 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 invisible particles. Invisible what? Particles. They can only be observed on a screen. They are invisible particles that can only be observed on a screen. They are invisible particles that can only be observed on a screen. Very important, very important. Number 4. They have the capacity to cause mechanical motion. Mechanical what? Motion. Take note of that. They have the what? They have the capacity to cause mechanical motion. They have the capacity to cause mechanical motion. Number 5. They are deflected. They are deflected to the positive side. Positive side of electric and magnetic field. Take note of that. They are deflected to the positive side of the electric and magnetic field. They are deflected to the positive side of the electric and magnetic field. Next one. Number 6. Should I write this one? You can pause the video and write them out. You can pause the video and write them out. You can pause the video and write them out. You can pause the video and write them out. You can pause the video and write them out. Number 6. They are made up of small particles. Number 6. They are made up of small or tiny particles. Tiny particles. Take note of that. Number 7. They possess kinetic energy. Number 7. They possess what? Kinetic what? Energy. They possess kinetic energy. They possess kinetic energy. Number 8. They can cause X-ray. Take note of that. They can cause what? X-ray. They can cause X-ray. Number 9. They produce fluorescent. They produce fluorescent. These are the characteristics of what? Of cathode ray. Cathode ray are negatively charged. They move in a straight line in the absence of what? Electric field and magnetic field. They are deflected to the positive side of the electric field. They possess what? Kinetic energy. They can cause what? Fluorescent. They can cause what? X-ray. They have the capacity to cause what? Mechanical motion. Please take note of that. Those are the what? Characteristics of what? Of cathode ray. They are characteristics of cathode ray. Please, I want you to take note of this. 100 level student and Jupeb. Likewise, Jamb. 100 level student, Jupeb student, and Jamb. Take note of this. Take note of this. Take note of this. The nature. Note. The nature of electrode. The nature of electrodes and gas do not or don't affect cathode ray. Do not affect cathode ray. Take note of that. The nature of what? Electrode and gas do not affect cathode ray. No matter how you change the gas and the electrode material, no matter how you change the electrode material or you change the gas from hydrogen gas to helium to do not affect the nature of the cathode ray. That means the nature of the cathode ray does not depend, nature of cathode ray does not depend on the material of the electrode and the nature of the gas. Take note like that. Take note of that. And take note, the ratio of charge to mass of cathode ray does not also depend on the material of electrode and the nature or the type of gas used. Take note of that. That means the ratio of charge to mass. What do they mean by that? The ratio of charge to mass of cathode ray. The ratio of charge to mass of cathode ray. That means the ratio of charge to mass of electron. The ratio, 100 level student, please, you have to listen carefully. And Jamb student, you have to listen carefully. Jamb student, 100 level student, Jupeb student, listen to this. The ratio of what? Charge to mass. The ratio of charge to mass of the what? Of the electrode and the gas does not affect, or the ratio of charge to mass of the cathode ray is not affected by the material of the electrode and the gas, nature of the gas. The ratio of charge to mass of the cathode ray is not affected by what? By the nature of the electrode and the type of gas. 100 level student, Jupeb student, and Jamb student, listen carefully. Please, Jupeb student, you have to listen carefully. Jamb student, you have to listen carefully. Take note of that. That means, take note of that. The ratio of what? Charge to mass of the cathode ray is not affected. Either if you change the electrode, if you change the gas, the ratio of charge to mass of the cathode ray of the electron is not what? Affected. Take note of that. Then let's move further. Let's know what is the ratio of charge to mass. Take note. Before that, let us move to what? Millikan experiment. Robert Millikan oil drop experiment. Let me quickly talk on that. Robert Millikan oil drop experiment. If they ask you, Millikan discovered the charge on electron using oil drop experiment. The man that discovered the charge on electron is what? Millikan. He used oil drop experiment to discover the charge on electron, which is what? 1.6 times 10 raised to power minus 19 coulomb. 1.6 times 10 raised to power minus 19 coulomb. That is the charge. That is charge on electron. Charge on electron. 1.6 times 10 raised to power minus 19 coulomb. This charge on electron was discovered by what? Robert Millikan using what? Oil drop experiment. Then Thompson and Millikan, they both discovered the mass of electron. the mass of electron, which is 9.1 times 10 raised to the power minus 31 kilogram. Take note of that. They both discover what? The mass of electron. That means J.J. Thompson and Robert Millikan. They both discover the mass of electron. And they discovered that the mass of electron as 9.1 times 10 raised to the power minus 31 kilogram. Then the ratio of charge to mass, E means charge. The ratio of charge to mass of electron is what? What is the charge of what? Of electron? 1.6 times 10 raised to the power minus 19 over the charge of what? The mass rather. The mass of electron. 9.1 times 10 raised to the power minus 31. Which will give you 1.76 times 10 raised to the power minus 11 coulomb per kilogram. Take note of that. This is the ratio of charge to mass of cathode ray. And don't forget, cathode ray is the same thing as electron. Why? Because electron is negatively charged and cathode ray is negatively charged. That means the ratio of charge to mass of cathode ray, which is the same thing as the ratio of charge to mass of electron is given as 1.76 times 10 raised to the power minus what? 10 raised to the power what? Do this for me. This one is 10 raised to the power minus 11 coulomb per kilogram. Take note of that. Take note of that. Take note of that. Please let me look at this. This is 10 raised to the power minus 19 minus 31. I'm sorry, it's 10 raised to the power 11. 10 raised to the power 11. Please, 1.76 times 10 raised to the power minus 11 coulomb per kilogram. That is what the ratio of charge to mass of electron. 1.76 times 10 raised to the power 11 coulomb per kilogram. Take note of that. The ratio of charge to mass of a cathode ray of electron. And take note, Robert Millikan, using airdrop experiment, he discovered the charge on the electron, which is this. Then both J.J. Thompson and Millikan, they discovered the mass of what? Electron, which is this. Then the ratio of charge to mass of what? Electron is given as 1.76 times 10 raised to the power 11 coulomb per kilogram. That means this over this. Take note of that. And take note, I told you, the ratio of charge to mass does not depend on the type of what? Electrode you use or the gas you use. If you change the gas, if you change the electrode, it does not affect the ratio of what? Charge to mass of what? Of electron or cathode ray. Then let us go to what? J.J. Thompson atomic model. What it says? J.J. Thompson atomic model. What it says? What did it say? J.J. Thompson atomic model. Number one, it says atoms are electrically neutral. Atoms are electrically neutral. Number two, atom is a diffuse cloud, which is diffuse cloud of positively charged. Of positively what? Charge. A diffuse cloud of positive charge, that contains negative tiny particles called electron. Take note of that. Called electron. Then the third one, it says, okay, I said atoms is a diffuse class of positive charge that contain negative tiny particles, negative tiny particles called electrons. And number one, atoms are electrically neutral. Atoms are electrically neutral. The third one, atoms resembles plum pudding and watermelon. Plum pudding and watermelon. That means he said you have something like this, then this is an atom that contains tiny negative particles, which are called electrons. They are embedded in atom. That the whole atom itself are positively charged. That the whole atoms itself are positively charged. They now contain what? Tiny particles. If you open your watermelon, those dot black seed, they are called what? Electron. While the red surface is known as what? Positive charged atom. The atoms is like that. Take note. He said atoms resembles what? Plum pudding and what? Watermelon. Then the last one, he said atoms is a sphere of positive charge cloud. Atom is a sphere of positive charge cloud. Take note of that. Take note, this one came out in Jupeb 2020 or 2021. Atom is a diffuse class of positive charge that contains tiny negative particles called electron. Then what are the limitations to this? Limitation to J.J. Thompson atomic model. Limitation to J.J. Thompson. Number one, lack of what? Nucleus. Limitations. Number one, lack of nucleus. Lack of what? Nucleus. That means they didn't explain that atom has nucleus. That means J.J. Thompson atom has no what? Nucleus. Lack of nucleus. It did not explain, number two, it did not explain. It didn't explain the stability of atom. It didn't explain the stability of atom. And the model was theoretical. The model was theoretical. The model was theoretical. But the significance about what? J.J. Thompson atomic model, the significance is that he was able to what? Discover electron. And he proved what? John Dalton wrong, that they are subatomic particles. He was able, the significance of his atomic model, he was able to what? Discover electron. And he proved what? John Dalton wrong, that there is subatomic particle called what? Electron. Please don't forget to press subscribe button, share this video with your friends, like this video, comment, and I remain myself, Jamb.